Well, welcome back everyone so far. We're just pretty much running the clock now. This text right here is pretty much a standing assumption. I notice that if I say it every single class moment, it becomes a little bit redundant, but always be in class a little bit early. So if you do have questions ahead of class, you don't have to wait for the official start time. But if you think it's a question everyone could benefit for, that's okay to ask right as soon as class starts. And it's official. Welcome back, folks. We're on our second day of a 16-week semester. We meet 3 days a week, so sometimes going from Wednesday into Thursday, that sometimes feels like the tough class, but we get through it. And we ended a little bit early. We're going to try to end usually closer to 8:40 for the full 70-minute class, but it's just going to depend on where we're at in the notes. If we notice we're going to start a new section and we have 4 minutes, that might be a good time to wrap up and just ask questions for the class rather than trying to race in 4 minutes into a whole new section or a whole brand new big problem, something like that. Well, any questions at all, folks, from you before we get started today? Okay, well, welcome back, everyone. Again, the class was a little bit in flux. Some people dropped, some people added the class just over the last couple of days. So if you're new to the class, you can see everything we talked about on the first day up here on the recorded lectures. And our goal is to record every single one of these lectures. I think that's really helpful for a very late night class like this one, just because things can happen on these really late hours, and that gives us an extra resource. Other things we mentioned was we went through the syllabus, we looked at the book bundle for accessing my lab statistics in a textbook, and this is a pretty good point to call for questions in the class. Have folks gone through the registration process, either through the book bundle link or the Access Pearson link? Anyone run into any kind of problem so far? Okay, and if you're brand new, then really all these links do is if you are in ISU's book bundle, you'll click up here to get your course Canvas page linked up with the My Lab Statistics courseware, which also includes an electronic version of the textbook. And it should be pretty streamlined. If you run into any issues whatsoever, please let me know. We'll get that worked out so far. I'm happy to contact tech support on your behalf, those kinds of things, because I know your time is pretty valuable and sitting on an 800 support line could be really tedious. I have some other people that I can email as well to try to get problems resolved as soon as possible. And I think a good start for us today is let's actually go back into that just to take another look at it. Usually on the first day of class, it's a bit frantic. I'm probably talking faster than I should. And it's hard to get every single detail retained. And I didn't want to click on that right away. So part of the experience in the class is 15% of the credit in this. Let me double check that. My percentages are different in every single class. I believe it's 15%. That or 10. Let's take another look before we just lie live on Zoom. So the homework portion is 20%. I definitely forgot. The quizzes are going to be worth 10% this class. And so 20% of your course grade comes from doing problems in the ISU book bundle. So you can either, once you're registered, click on either one of these links and it'll take you to the My Lab Statistics right away. I'll just click on the book bundle one. I think that's the one that encourages us to use, but this one sometimes skips a page and it's a little bit faster. I think anyone can use it once you've already linked your Canvas. So let me go launch courseware. You can tell this is kind of hacked together when you have to click on a whole bunch of launch buttons. You should see something along these lines, a button to open My Lab and Mastering. Should say My Lab Statistics, but we'll get the name down right one of these semesters. Your page doesn't look quite like this. I need to click on View Student Home and remove this tool for the moment. And this is what the courseware looks like. Again, just a reminder to get the e-textbook, click here, then click on whichever chapter we're in. It's a lot of clicking. That's kind of tedious. Then click on the very bottom under e-text resources. It feels like they kind of bury this under here, but this is where the textbook is. And that's how you access your textbook. We mentioned before, any kind of pre-reading you do inside here is really helpful to the class. Statistics is pretty terminology heavy. There seems to be sometimes There's a lot of vocabulary you have to master to get a real good feel for it. And any kind of pre-reading you do inside here is really helpful for understanding what's happening in class. You can pop out the table of contents to go to the different sections that we're in. And we're running through pretty much all of chapter 1 in one big set of lecture notes. It's actually a pretty small chapter. Aside from that, I just close the textbook when you go back to course home. The way you do your homework is just go down to assignments. That's the better thing to click on. And they're all just going to be listed here. Each time I post a new set of lecture notes, I'll post a new document, or excuse me, a new problem set here on the MyLab Statistics courseware. It says MyLab Math here. Again, they'll get the name right eventually. Maybe statistics is just too big to put in, I suppose. The due dates here, just as a reminder, they're not firm. I don't have a late policy, so if some of these go beyond and you want to improve your course grade, you can do so, which is really helpful because this is worth 20% of your entire course. Think of these due dates as really pacing. If you're getting everything done by the due date, then that's my estimation for you that you're well caught up for the course. You're going to be in a great position by the time the first exam comes. So just go through these, try to get them up to 100%. You just have to click on them. And notice I never saved anything last time I showed this. Everything auto saves once you submit an answer. That's kind of helpful. There shouldn't be any kind of issue where you lost your internet and the whole assignment's worth of work just disappeared. Go to whichever problem you're working on, or resume button works just fine. And this is what the problems look like. It's an interesting way to do homework problems, but the major idea here is we're just trying to connect some of the concepts in a really fast way to see what some good questions will look like. Exam questions aren't going to be multiple choice, and there seems to be a lot of multiple choice problems on this. That's why I'm also assigning additional quizzes, so you can get an idea of what does a real exam question look like. So think of this homework system here. It's usually going to be 4 to 5 questions. It's not meant to take a lot of your time, but it's just like a concept check after you come to class, after you read the section or chapter. I'm showing you what are the major concepts you should be aware of for mastering the content on the quizzes and then the exams. We're on question 2. I won't try to answer this one, but other things you can click on are, well, hopefully you never have to click on that button, but if something goes wrong, that's a good one. I want to emphasize this again. If you're doing a problem and you're not sure what's going on with the question, you can always click on Ask My Instructor. It sets up a message system, and I'm going to double check that everything gets sent correctly. It looks like it does go to my ISU email. That's the short version. I'll see a notification in my email, and from there, I'll go back inside the system and respond to you. You can use this as many times as you want. There's no limit on this. So I encourage you to use this quite a lot. If the question is vague, if you're not sure, for example, sometimes really great questions here are, you found the right answer, but you're not sure why it's the right answer. Those are great questions to send out as well. And there's no limit to how many times you can ask these kind of questions within the system. I'm a pretty fast typist, and I'm really happy to help out in that kind of way. Especially because, this is a night class. My office hours are 4:15 to 5:15 before my first class of the night. It's sometimes probably really hard for all of you to actually make it into those office hours. You're probably in work, possibly in another class or commuting. And so either using this system or directly emailing me questions is a great way to get additional help. Another fun button you can click on is just the textbook. If you click on this, in theory, what this should be doing is taking you to the most relevant spot on the textbook to what this question came right out of. Looks like it's a 1.3 variables question. And so this is an interesting way to kind of do the reading or refresh on the reading. This will give you the information you need to know to answer what this question is about. And it's going to skip around the textbook a whole bunch through the questions, but learning is sometimes kind of chaotic in that way anyways. So that's a tremendous resource as well. If you miss a question, it tends to give you a little bit of hint. If you click on the textbook, that might help you recall what was this question really all about. Then every time you click on check answer, it saves your progress. I think there's something like 99 attempts per question. But if you're going through this and paying really close attention to what the question is all about, retaining why a problem is wrong and the other is right, then you're using the system at its best. If you're running through it and just collecting something by trial and error, ripping through it, then, I mean, you'll still get the credit, but now studying for exams, so it's going to be a lot harder. The quizzes are probably going to feel a lot more mysterious, and it just wouldn't be the most authentic way to get through the system. I'm never really going to be able to tell, so it's all kind of on your honor on that. 99 attempts is kind of opens up multiple choice questions for weird ways of doing them. But again, this is 20% of your grade. I didn't want to put it down to like 3 attempts. Now have everyone just get it nickeled and dime for points all semester. It's only meant to help you not to chop away at your grade. So we went for that as a compromise. So that's my rundown on how the textbook works, the homework works. Any questions whatsoever at the moment, folks? Okay, well, let's get back to our page here. My annotation tool's clear on the left. There we go. Again, usually I start class with lots of just markings of annotations on the Moodle website. I'll usually say where exactly we are, what example problem you might be on. I might jot down a quick formula, but anything that's on here will be saved on the recording, but it's not critical information you have to rapidly jot down if you came in class like on the last couple minutes. If there's something important here, it'll also be in the notes itself. So these are usually just kind of quick reminders. The other reminder is we're updating these files as we go. This one has already been updated. So if you prefer to open up a fresh document, it's all going to be contained in here. And if I ever forget to just upload something, please let me know and I'll get it taken care of right away. The other thing that I sometimes forget through the semester, which can be kind of annoying, is if you're trying to come back to the lecture and it seems like it's just missing, send me a quick email and I'll get it corrected right away. Probably what happened is I put it in the wrong playlist or something like that. Well, that's our, this time just an 11 to 12 minute spiel, not taking full 15 minutes to talk about the course. Here's where we left off, and this is pretty much how the day is going to proceed each time we come back to class. I'll have some announcements to run through. I'll call for questions, and you can ask about anything, whether it's a problem in the homework, something about upcoming exams, anything you'd like, and I'll be happy to take questions. At the end of the questions, we just dive back into where we left off and proceed through the course. So here's where we left off. I should ask first, any questions at the moment? Okay, let's get started then. We didn't get too far on these notes. I think I had enough time to open these up and mention these are really important definitions that will come back all semester. But this is also a good page to go carefully because we said example 1 is also a big introduction to the entire objective of this 16-week course. What is statistics really about is answered in example 1. And sometimes I'd like to be kind of upfront with these examples. Sometimes these examples are not a good exam question. Kind of a weird thing to write down, but the purpose of this example is not something I'm going to ask again. It's just our way to try to really learn these two big core definitions that show up again and again throughout the entire course. And notice how hard it is to learn these definitions. It says the population is the entire collection of individuals, maybe people or objects that you want to learn about. A sample is a part of the population that is selected for study. And that's it. If you're like me, you probably didn't learn much from that. It's really hard to say what they're trying to convey just from those definitions. They sometimes get pretty technical. They're sometimes very brief like this. And to get a real good feel for what this is all about, we need to dive into an example. So here's our pretty short looking example that's going to highlight both of those definitions. Let me scroll down to about right here. So this says, the San Fernando Valley residents are okay with a 1 cent transit tax. Some MTA poll says, probably a newspaper or article, maybe something online otherwise. What it tells us is the headline of an article that appeared in the LA Daily News. So I don't know exactly what an MTA poll is, but San Fernando Valley is a really large place in California, and Californians drive like crazy, so a 1 cent transit tax may not sound like much, but that could probably add up to quite a lot of money over time. It says the residents are okay with the 1 cent tax after a poll. They tell us next, this headline was based on responses Not from everyone in San Fernando Valley. That's a huge, huge place. California is like a whole new country, a whole new reality. It was based on just 100 San Fernando Valley residents. Our job is to describe the sample and the population of interest for this poll. So let's sketch this out. This example is a little bit bigger than it looks. We're going to go beyond just answering that partial problem and talk even a little bit more about population and sample. Well, let's start sketching this out. Population and sample. Anyone happen to see, just from reading those two lines, what the population would really be in view of the definition above?
The residents, right, would be the sample.
Kind of depends on which residents do you mean. Do you mean all San Fernando Valley residents, or do you mean the 100 San Fernando Valley residents? Yeah, absolutely. A great way to think about this is if we say the sample is part of the population, we usually mean a small part, and often in statistics, because gathering people in a sample is expensive, sometimes it's a really small part. 100 residents from a landscape that has millions of people is minuscule. But that's our sample in this problem, the 100 San Fernando Valley residents. Let's write this out here. I'll write this briefly, the 100 residents. Notice I'm leaving off the fact they're from the San Fernando Valley. I'll just say briefly, the 100 residents selected for study. Then we have to say what the population is. The population is the entire collection of individuals, not a small part, but everybody. So it's really just this, San Fernando Valley residents. But usually, just to emphasize what we mean, we often start by saying all. You wouldn't lose points if you left that off, but it's a good idea to say it on the notes because it's a reminder you're talking about the entire collection when you emphasize by saying all. So here, I'll be a little bit more descriptive and say all San Fernando Valley residents. So the population is everyone who resides in the San Fernando Valley. The sample is the 100 residents selected for study. And notice it is curious. I didn't say down here 100 residents in San Fernando Valley. You could have it, it's just fine, but you don't have to because we already know the sample is a part of the population. So by de facto, these 100 residents are already known to have came from San Fernando. You don't necessarily have to say it twice. It wouldn't hurt if you did, though. So that's the population, that's the sample. And let's do a bit of a big diagram here. I'm going to put a big bubble over this one. At this point, we would have answered the question. So now we're adding a little bit more detail of what we're trying to achieve in statistics. So here's the big problem of statistics. The way they got that sample is really, really important because we want these 100 residents to represent everybody, all San Fernando Valley residents, in a really nice way. You can imagine how this could go wrong. Imagine we're talking about a population that is all ISU students, but my sample is just everybody in the classroom today. Would you say everybody in the classroom today represents every single ISU student? So I'm saying no right away. It's biased, right? We're in a satellite campus. We're taking a very late night class. We're probably mostly non-traditional students. So if we base our opinions as representing the entirety of ISU, that's a really biased set of opinions potentially, depending on the issue. So the way they got this sample was very important. What we want is this to happen in statistics. Sample is selected at random and representative of the population. So we need to talk a little bit just on how we would do that. This is an introductory textbook and course on statistics, so we're not going to talk about every single sampling design in exhaustive detail. Our book has one sampling design that we'll discuss a lot, something called a simple random sample, which happens to be random, it's in this title, and well representative of the population. So if these 100 residents are randomized so that biases even out and represents the original population well, we can trust whatever data we get here to represent the underlying population. So here's where we have our dichotomy represented again. For the population, there's this new variable called p, lowercase p. And for the sample, there's another variable called p hat, is the way we usually say that verbally. P with just an arrowhead right above it. There's a new set of definitions that go along with this that we'll discuss a lot along with population and sample. This P over here is called a parameter. It's a parameter because it will describe when we say what it is, the population. This P hat on the right-hand side is different. It does not describe the population exactly. It's estimating something about the population. What it does describe exactly is the sample. So this one has a name. We call this a statistic. Let me put the word in front, it just reads better. A parameter, and this is a statistic, which is kind of cool. We're getting to the title of the whole course, statistical reasoning. A statistic, and this is because it describes the sample. Once we get pretty far into the course, think maybe the last 4 to 5 weeks, the hardest thing that happens in the course is we have to describe our own parameters by reading through the context, deciding what is the population, what is the sample, what is the study trying to achieve. And a lot of this is going to be a skill that we practice over time. Essentially, just about every single class period, we're going to be looking at problems like these, learning to read the context to separate out population versus sample, statistic versus parameter, primarily in the last 4 to 5 weeks of the course. So let's write out what these would be in this problem. So the population is all San Fernando Valley residents, but what did they hope to learn? We want to know if the residents would be, let me target this highlighting a little bit better. That's for population. And what the study is trying to determine is if they're okay with the 1-cent transit tax. So they're about to tax Californians. That could go ugly. And we were just trying to gauge opinions, in other words, before a law actually goes into effect and politicians start to debate and just throw slurs and stuff like that at each other. So these kind of polls are really very common. And P might be determined by writing down P is equal to the population. Let's make it possessive. The population's proportion of residents okay with the transit tax. So this is the thing that everyone wants to know about. The word proportion is kind of confusing here, but keep in mind, proportion is entirely synonymous to percent. Kind of annoying in a way. I think if you say percent, people understand that word a lot better. In statistics, we often say proportion a lot more often, but always kind of highlight that as if you said percent right here in your notes, in your conclusions to a long problem, it's totally fine. Sometimes that's even a better conclusion because more people might understand you if you said percent. So P is the population's proportion or percentage that are just fine with the transit tax. I didn't say this entirely verbatim. I kind of paraphrased it, put it in my own words. It just has to convey what we were trying to say up here. Now, this number, it's a percentage of people fine with being taxed, is almost impossible to get. How would you get it? You would have to conduct a census, which means contact every single San Fernando Valley residents, every one of them, and gauge their opinion on this. It's just financially impossible. If you had the money to make this happen, it's a temporal problem too. There's not enough time to conduct such an enormous large scale thing. By the time the study's done, opinions might have shifted already from when the original question was posed, because months, maybe quite a lot of months, could have gone by. So we have to give up on trying to estimate P. In a statistical problem, the ones that we study in class, P is what we want to know, yet P is unknown. This is the big problem. This is why this course is 16 weeks, not 5 weeks, because determining how to best estimate P, a major unknown, the most important part of the whole problem, is what inferential statistics is really all about. It's kind of a funky science, and it goes back to your sample. We can't poll millions of people. The federal government does take a census, but think about how much money that costs and how much manpower that costs. And also wonder, is that census 100% accurate in the very first place, even after they do their entire maneuver for our census? It's a lot of vague things that go on. So what we're going to do instead, what the LA Daily News is reporting on is a study that collected a sample. Now we just have 100 San Fernando Valley residents, and sure, we can poll those people. 100 people is still a costly study, but it's feasible. This could get completed. We just have to make sure we didn't just grab anybody that's convenient. It was a random and representative sample. If that's the case, these people should represent the population well. And P hat, let's define this, is going to be the samples. Let's make that possessive as well. The samples proportion of residents, okay, with the transit tax. Let me highlight that in yellow again. Probably made these bubbles a little bit bigger than they had to have been. Let me see if I can make this a little bit easier to look at. The black arrow coming out of here is just a way to convey we got the sample because it came from, through that arrow, the original population. So here's the nice thing about statistics. If we did all the hardest work of finding the right randomization, the right sampling design, and we have a representative sample, everything from then on becomes so much easier because P hat is known. We can find and calculate that value. We don't have the same struggle on the left with the parameter being unknown. In statistics, the parameter is always essentially unknown, and it's the statistic that we actually have a number for. Let's do a little bit of an example on this one because still it probably feels a little bit foggy what exactly we're saying. So let me put in a little box here to say, we're going to just do a quick example to illustrate this. How is P hat known? How do we calculate it? It would look like this. We actually kind of go like this so we can gauge how big this will get. Let's just call this a, for example. So this is just a random scenario. I haven't read this article. It's a real one. If you ever want to look up these kind of problems, you never have to though. So I'm just going to make up the data. They gathered 100 residents and they just interviewed them and asked them, are you okay with the 1 cent transit tax? So let's just assume for our own sake that how about 56 of them said, yes, I'm okay. let's say here, assume just for the sake of example, 56 people in the sample are okay with the tax. Then this is what we get to calculate. Recall, p hat is the sample's proportion, but it's just a percent, and percent is a quantity out of 100. Also, we have 100 San Fernando Valley residents, which just makes it easier to calculate as well. We'll have here p hat is going to be the 56 people that were okay. That's the question. Are you okay with the transit tax? Divide by the sample size, which was the 100 residents. Let's make this pop out somehow. We'll divide by the size of the sample, and we'll give these formulas in a more very specific way. Think of this again as kind of a preview example of calculating this kind of statistic, p hat. But if it's 56 out of 100, then this would be 56% is one way you could write it. Just as good, if you want to write it as a proportion, you would go 0.56. That's a completely different unit, but the same exact information. So it's really up to you if you want to write down the percentage or the decimal number. If you're doing our homework in MyLab statistics, I'll often tell you, give the percent or give the proportion, and that's a signal to you. You're either using 56%. Sometimes they print the percentage symbol to illustrate that as well, or you're just giving the number 0.56. So we've got a known value, p hat, in our just small example to say what we're going on, how p hat is really known. We calculated it down here. Any questions about that so far? Okay, a lot of ideas are going together, right? When we proceed through this bit by bit, it looks like kind of a mess, and sometimes that's the benefit of the YouTube video. Looking at this is really hard on the eyes. It's like a cloud of information. What's more important is how each element occurs step by step as we build up the overall concept. And this is the overall concept down below. Here's what we refer to as inferential statistics. We've teased that word a few times. We've said that this is what the course is all about. And here's literally what we do in inferential statistics. We take our frustration, the fact that the parameter is an unknown quantity that we want to know about, and we write this. P, the population's proportion of residents okay with the tax. Little squiggly lines is just a way to say is approximately equal to. Let's make that specific. So the population's percentage of people okay with the tax is approximately equal to whatever p hat was in the sample. So that is our big claim. And this is what people would report. We can now estimate that for all San Fernando Valley residents, if it was 56%, then the population's proportion is approximately equal to that 56%. Then they go to publish it and you start to see headlines. Where is it? The Valley residents are okay with the transit tax because it came out as above 50%, so it's now a majority. Not exactly a super majority. A lot of people are probably pissed off about it. But if it's above 56%, they'll literally say, yeah, they're okay with it. Kind of weird how some of these studies kind of go. Any questions to this stage so far, talking about inferential statistics? Okay, yeah, go ahead. Yes, absolutely. In a larger full problem, it'll literally tell us on the next line, after surveying the 100 San Fernando Valley residents, they found that 56% or 56 people were in favor of the tax. So they'll write in that information to the problem. This problem's confusing because it didn't give us too much to really go off of. Other questions so far? Okay, all of this sounds lovely. And if this was the full story, our course would be maybe 8 weeks long. It's a 16-week course because there is a humongous, glaring problem here. It's not about the sampling. If it really is random and representative, then it's okay to say approximately down here, but there's still a humongous problem with all of this. Anyone see what it could be? Yeah, go ahead. Absolutely. If they didn't do this at random, we have just a totally terrible data over here. And people would point that out immediately. People are really good these day and age of the internet age and like all sorts of social media of taking a study, finding out how it was actually done. Doing that research is easy these days. If any mistake happens, it gets torn to pieces. So if the sampling wasn't random, absolutely, this is completely falls apart. The approximately probably isn't even true either. But let's assume the randomization did work. They did everything right. It was done at random. It really is representative. There's still one big problem with saying 56% represents the population in favor of the transit tax. Anyone see what the problem still would be?
The sample size compared to the actual population.
That's a really good question, and you're getting very close to that. Sample size is important because it has something to do with accuracy. The bigger the sample is, the more accurate this approximation is going to be. And that's the glaring thing. We can't just end right here and say P, the unknown, is approximately 56%, like in this simple example, because here is what is majorly missing. This is what makes it a 16-week course. Right there, massive problem. We must describe how accurate the approximation is. So any approximation you're given, any context, not just statistics, approximation without a discussion on accuracy, without anything talking about margin of error, for example, is a useless approximation. This could be off by 30% maybe, and you could still write down approximately equals to. Turns out the accuracy does have to do with the sample size, so that's part of the key to all this. And again, this is what makes this course a bona fide 16-week semester course. Describing how accurate that really is not easy. It's going to take us through weird things like probability, normal distributions, and eventually the answer to this question will loop back to this page right here when we get to it is we are going to get something called a confidence interval. Not just one number, but a whole set of numbers, the percent from a low end to a high end, which we'll call 95% reliable. We'll call it a 95% confidence interval. Or maybe we want to be more confident and give a 99% confidence interval and so on. But that would be our discussion of the accuracy in the estimate. So this is the big problem with statistics. Getting this p hat, this is called descriptive statistics. This estimate is called a point estimate, but again, all of it is useless until we know about their reliability. So that's what this course is really going for as its ultimate major objective. But any questions at all, folks, with the ideas so far? Okay, big takeaway so far is really just the major dichotomy of population and sample. The ideas of parameter versus statistics seem a little bit vague so far. That's okay. We're going to cover these in a lot of detail as we proceed throughout the course. Next thing we want to talk about after this introductory example one is data. We know what the population is. We know what the sample is. When they get the 100 residents, they begin collecting data. So we just need to have a little bit more of an introductory example of what do we mean by data in the very first place? This is one of those examples that probably wouldn't make a very good exam question either. It's quite long. But this one comes into the homework a little bit. In the homework, you're going to be asked about the who and the what, not the whole five W's and how. But I felt like we should go through all of it just to give another example of what do we mean about data. Statistics is all about dealing with data, so doing a long example like this one is probably another good idea. So let's say for this one, just as another hint on exams, this is probably another intro example. It's not a great exam question. The whole purpose to example 2 is to define and really say what do we mean by data in the very first place. So that's our goal. And we're not going to say this on every single problem we cover. If everything we cover is not on an exam, it starts to seem like it's meaningless after a certain point, right? But again, think of this as just a hint that the whole purpose of example 2 is for us to learn the definition of data in the very first place. So again, this is tough. If you're just reading the definition, it says we think of data as collecting a collection of numbers or characters, images, or items that provide information about something. And that feels like it's about as vague as possible, but it has to be. Data is a big idea. The big thing that we need when we're dealing with data is what is the context? What's the data all about? Who is it trying to describe? And that's the so-called five W's. I never liked the five W's when I had to deal with this in the K through 12 education system in Idaho, but it comes back again. This is the only time it's coming back. It's just a good way to think about what data is. So the context is going to tell us the who was measured. That might sound familiar already. Sorry for the red scrolling, just matching my color coding. The who is the sample. So the context of the data will tell us who the data is about, who was measured. Again, that's just going to be fully synonymous with sample. What was measured is a new idea we're going to define in the next set of notes or the next examples. Let's just write this down as a preview. The what we're going to later call the variables. How? Well, that's the sampling design. How did you get your data? Did you just interview people as they came off an escalator, for example? Or did you get a list of every resident in the county of Bonneville and then use computer software to randomly select 30 of them? All of those are really important questions. It tells us, was the data random? Is the data representative? So how is, let's see, what's the best word here? How the data was collected. Maybe too much information is a bad idea. I think that's pretty self-descriptive. Or let's maybe add a little bit. Is the sample random? That's the overall thing we're trying to answer by discussing how. Notice how weird this feels. This is the 5W. That's not a W, that's how. So there's really 6 things here. Again, that's another thing that always irritated me about the 5Ws. It feels like a lie already. But how is an important part of this? We want to know, is our data even going to represent the population well? Where the data were collected might be important, so it's part of the 5Ws. When it was collected, that could be critical. Sometimes think of the transit tax, that's an opinion thing, and opinions change with time. So you wouldn't want to read a study about people's opinions in the 70s and apply it to 2025. It's completely ancient data at that point. So when is important? Why is interesting because sometimes the why is not easy to determine. Sometimes there's certain motives behind studies that people would never have guessed. Sometimes you can determine the why by who gave money for the study, who funded it. Was it the federal government? Was it the dairy industry? Something like that might inform you about the why. It's not always as apparent as we would like to think. But this is the so-called 5Ws. And one thing that's kind of annoying about these problems, really another reason why it's not a great exam question is we can not always give an answer to these 6 parts, the 5 W's and the how. It just depends on what did they give us in the context of the problem. So we do the best we can. Sometimes we have to give an estimate, say on a time component, we might say it's unknown when this happened, but we think it happened before this time. Sometimes, for example, the why is just a complete mystery to us, or maybe we have a good idea on the reason. So when we go to do this in example 2, we're going to try to see which ones we have great information on and which ones are actually just unknowns. As we do that, we get a good feel for what is data really. Well, any questions at the moment, folks, with the definition? Okay, these are pretty long examples. Not every problem we do in class is going to take this long, but again, these are kind of like startup questions. Example 1 was a long one to say what are statistics all about. Example 2 is a long problem to determine what did we mean when we say data in the very first place. Now, this is another thing that's kind of hard about statistics. It's uncomfortable, especially if you like an ordinary math class. Most of your problems have zero context. In an ordinary math class, it's something like solve 3x plus 5 equals 4. And that's fantastic, right? You just go through the tricks of the trade and you're done. You don't have to think about the answer. You might check it, and that's about it. Zero context whatsoever. This is where a statistics class starts to get a lot different. Our problems aren't like that. They're like this, the highlighted text right here. This is like an abstract. What I mean by that is, this is a real article. It probably is several pages long, but sometimes when you're discussing an article like this one here in Stats Winter 2004, an abstract is just a short blurb to tell you what it's all about. So we read a lot of things that are functionally like abstracts. It's not going to give us everything we might want to know about the problem, but it's giving us enough to tell what is going on in this study. So let's read through this. Another interesting thing about these kind of problems is we're learning what the context is, what's really going on, and it really is tricky at the start when you're beginning in a statistics class. Breaking down this information, determining the context, what's happening really, is not always an easy skill. Some people are extremely fluent at it. If you're like me, this is something you're going to build over time on a week-by-week basis. This is what made me uncomfortable when I first took a statistics class, dealing with all these word problems. I liked just the contextless math problems, like solving an equations better. Well, let's give this a try. I'll often read these out in class as well, so we can read through them together. It says, people who get lost in the desert, mountains, or woods often seem to wander in circles rather than walk in straight lines. To see whether people naturally walk in circles in the absence of visual cues, researcher Andrea Axtell tested 32 people on a football field. So this is a pretty interesting kind of like survival information. You can imagine you're over the Sahara Desert, your plane goes down, you're trying to walk to the nearest civilization with no visual cues whatsoever. It says people who get lost really seem to often wander in circles and just perish to the elements, which is tragic, and it's kind of curious that that happens. So we want to do a study, see what's going on with human nature, human walking, ambulation. Does this happen naturally, or are these just weird occurrences? So researcher Andrea Axtell did this with 32 people. In a football field, one at a time, they stood at the center of a goal line on one end. Already, we might assume that this is American football, but notice it's not very specific. You are probably bringing in your own assumptions when you're thinking about this. So you're at one goal line, you're blindfolded, and then you try to walk to the other goal line. You're probably told, go to the other side, or maybe a whistle blows. I'm not sure how she conducted the study. She recorded each individual's sex, height, handedness, the number of yards each was able to walk before going out of bounds, and whether each wandered off course to the left or the right. So, anyone happen to know how many yards a football field is in American football? 100 yards. So, we're probably assuming this is 100 yards. Again, it's not super specific, but you're never supposed to buy the article and read the whole thing yourself. If you brought in some of your own context and you assumed it's American football, so it's 100 yards, that's always totally fine on a homework question, on a quiz question, and an exam question. So take what the context you're given, make the natural assumptions as you go along, and that's always just fine. We're told after walking 100 yards, and you started in the center, anyone know how wide American football fields are? I have no clue on that one. We know it's 100 yards, but how wide is it? Let's do a little research. That's kind of interesting. How wide is an American football field? Well, if you trust AI, they're saying in terms of yards, let's go with yards because we said it's 100 yards long. It's about 53 and a thirds yards wide. So they're in the center. That means 53 and a thirds divided by 2. We're starting to do a lot of math here. That's the amount of yards. Let's see. Let's just re-emphasize one thing we said about this class. Anytime you have to do a computation, it's always good to have this on hand. You don't have to work super hard on these kinds of things. 53 yards and a third. Any computation I might do in class, I'll always demonstrate with this calculator, since this is going to be one of our big tools on exam 2 and so on. Divide by 2, and we're looking at 26 and 2/3. I'll just call it 26.7 yards. So everyone started at the middle. They had to go 100 yards. Everyone deviated by 26.7 yards. They probably would have deviated more because they just stop them once they go out of bounds. It's kind of interesting. So maybe that kind of answers the question. People somehow have a bias. They record a lot of information. I'm not sure which ended they ended up on, how many, but she did record that. And that's what this study was all about. So if you're like me, you probably lost some of those details in your mind. Another thing that's tricky about this class is reading the problem once is not always good enough. Sometimes you have to read it twice. Sometimes you'll answer the question. Imagine you're doing a quiz problem or an exam problem. After you answer the question, you might want to read it a third time to see if all your answers really make sense anymore with the overall context. We're not going to sit here and read it 3 times out loud because that would probably bore people to tears, but it's just something good to mention. It's natural to need to read these several times. Not necessarily for everybody, but if you're someone like me, that's probably something that is a good skill to work on. And the more you practice this, the more things start to stick in your mind more. This is like anything else. It's a skill that just gets better over time. Well, let's scroll down to this part here and identify the 5 W's. First up is the who. The who was measured, or we said above, it's the sample. Anyone see what the who would be in this problem? Absolutely, good call on that one. This is the sample. Kind of curious because we didn't say exactly what the population was. We'll get to that portion later, so if you're thinking about it, good on you. But the who is the 32 people tested. It's okay to be a little bit brief on the description of who. You're really just describing the sample. These are totally synonymous because it's usually the population we give a little bit more detail on. The sample always came out of the population as well is what allows us to get away with that. If you said the 32 people tested that can walk normally, then that would have been just fine as well to give more detail if you wanted to. So that's the who. The what is a little bit more tricky here. This deserves some highlighting. I keep changing my mind on what I want to scroll to. The what is something new that we're going to call variables. And anyone see what the what should be in this problem?
The height.
Exactly. It's the stuff that was getting recorded as this researcher, Andrea, tested each person individually. It said, let's see here. Well, this is just how the study proceeded, right? They tried to walk from one end to the other. But this is like what you're saying. This is the what of the study. the information recorded, measured, and so on. So let's just highlight all of this as being the what. So writing it down, this is a little bit tedious because imagine you're trying to do this if it was a quiz problem. You may not have a highlighter, so this is not a fine way to answer the question. I'll often highlight things in notes whenever there's lots of moving parts. Sometimes it just helps your mind to really pick out how things connect with some kind of highlighting. So I'll copy that in my notes quite often. Some people decide to use colored pens on exams and quizzes as well, if you like this kind of strategy, and that's completely acceptable if you prefer, but it's totally optional as well. This is a bit tedious, so let's write this out. I'm not going to write it down verbatim, so let's see if we can paraphrase. Should record each individual sex, so I'll just say here sex, height. The first time I read this, I did get a little bit stumbled on the word handedness. All they mean is left-handed or right-handed, which is interesting. Maybe people who are right-handed wander off to the right, or maybe she found something totally different. Right-handed people wandered off to the left, left-handed people wandered off to the right, or maybe no pattern whatsoever. Who knows? We'd have to look at the data. So let's just say handedness. And number of yards each was able to walk before going out of bounds. If this is an exam question or a quiz question, you can paraphrase these kinds of things. If you just said yards, that's okay, because information here is a context that explains what you're trying to say right here. If you wrote out number of yards, that's fine as well. If you wrote out number of yards each was able to walk out before going out of bounds, that's okay too, but sometimes I encourage you can paraphrase because the last thing you want to do is take a 70-minute timed exam and write down every single word because your head is going to get tired. You could run out of time even when you know the material perfectly. So it's okay to kind of paraphrase here and there. I'm not trying to write it down long exams that you're going to write forever, but there's been some cases where even on short exams, people included so much detail that it was a burden to complete it on time. There's no harm if what you wrote down can be extrapolated as what you mean in the context. So just check your work, check your context. If it makes sense to you, it probably makes sense to me as well. Next one is whether each wandered off course left or right. Let's maybe paraphrase a little bit. Off course side. Side meaning off to the left side or off course to the right side. So that's the what of the study. That could be a lot of writing. You're encouraged to shorten things up so that it feels reasonable. I'm never going to write a quiz or exam question where you have to just copy the whole thing down verbatim. Well, that's the who, that's the what. Next is the how. Well, we kind of saw how it went. That's this part of the context. This is Andrea saying in a very brief abstract the way the data is collected. How did she get how was the data collected? One at a time, they stood at the center of a goal line, were blindfolded, and tried to walk to the other goal line. Again, you don't have to say that verbatim. You can paraphrase this. Some people might be already writing it down. Any volunteers for a paraphrased version of that highlighted text here? Any volunteers for putting down the how, but it's going to be this information here, just paraphrased. How would you all shorten this up? Yeah, that seems like the whole heart of the study, right? No visual cues. You're blindfolded now. Blindfolded subjects. Then what else happened? Asked to walk to the other side, and that's how she collected her data. To the other side. So that would be a perfectly fine way to paraphrase it. I didn't say everything, right? I missed certain things, like that they stood at the center of one goal line. For example, that's not there. But again, you don't have to say every single thing verbatim. If I can extrapolate what you're meaning, I'm now imagining, yes, they're blindfolded, they're walking to the other side, so they're probably starting at the opposite side, probably in the middle. It just makes sense. That's good enough for me. That'd be a great way to answer that kind of question. And sometimes on exams, people have a lot of different ways to say the same exact thing. There's one, two, three, four, five, six, nine people in class. If this was a real exam question, again, it doesn't make a good one. But if it was, it's not too unusual to see nine different ways to say the same thing. Maybe one person did write it down verbatim. That's okay. It just takes a lot of extra time. But then eight other people might have found different ways to paraphrase that information into just a slightly shorter statement. So that's the how. How about the where? Any volunteers to say what's going on with the where on this one? Absolutely. The where is a football field. Let me spell that correctly though. But here's where it gets vague, right? Do we know anything beyond that it was a football field? It could be important because maybe they're doing it in Idaho and they're doing it in maybe January 10. It's cold out, right? So that could possibly have some influence on the study. But if you read through this, it wasn't done in the desert or the mountains. That's like the larger thing that we're curious about. We're just told, let's see here, 32 people on a football field. So it's a football field, but otherwise, the rest of this is a humongous unknown. So we just try to answer the best we can on these. If all you said is football field, I think that's a great answer. And sometimes I use orange to say, here's another just fine equivalent answer, or sometimes orange is just a comment. Let's put it here as an equivalent answer. Or another fine answer is just simply unknown. If you just said the where is straight out unknown, I think that's okay. We know it's a football field, but we don't know if this was conducted in the United States of America. We don't know if this was conducted in, say, Greece or Italy. We have extremely limited information about this. We did make some assumptions, which might say we're probably in USA somewhere, but that's kind of speculation at this point, right? So sometimes unknown is a best answer to these kind of questions. These kinds of abstracts I can read through here don't always tell us everything we want to know. And sometimes it's good to know what the missing information is in the very first place. Sorry for the random scrolling there. So the where is very minimal. Good eye though. We do know it's a football field, so it gives us some idea of how the study is carried out, what's going on. How about the when? Any information on when? That's a good call. It was in the winter 2004, but that's slightly problematic as well, right? Because that's a published date. She might have done the study and published it right away. Or sometimes with these kind of journals, you do your study, you submit it to a review board, and they're going to look, how did you collect your data? Was this really done well, step by step by step, before we actually publish this for you? Sometimes a review board could take a really long time. It could be months, it could be years in some cases for some journals, but we still have pretty good information. For the when, let's say winter 2004. If you stopped right there, I would give that full credit, but it's probably better to say winter 2004 or sooner. You might have said winter 2004 at the latest date, but we don't know exactly when the study was conducted. Maybe it doesn't matter as much when it's conducted. This isn't about people's opinions on politics, like the 1% transit tax. When is very important there, but it's still good information. Next is the why. Why did we do this study is a very, very good question here as well. This one can sometimes be very open to interpretation. This is another reason why this could make a terrible exam question. We won't ask one directly like this because this is more subjective, I would say. With very limited information, this is subjective kind of question to answer, but I think this one does have a pretty good answer on it. Any volunteers for why we did the study? Yeah, exactly. So that takes us right back to this original statement here, or the original first part of the context. So good eye on that one. This is really what we were trying to learn about. We're thinking about people who get lost, wander in circles. And so we want to see, well, what would happen if we tried this out in a football field? So let's put this down into the why finally. Last one. And let's see, this one's another one that's kind of hard to paraphrase. Let's just say for the why, to determine if people walk in circles with, you might just say, do people walk in circles blindfolded? And I think that'd be a pretty good way to respond. It's well paraphrased, but it really feels like the visual cues is a big part of this whole idea right here. Again, imagining someone lost in the Sahara Desert, nothing but sand everywhere you turn. You can't tell how far you've turned at any moment. So I'm going to go against my advice I do normally and just really write it out with no visual cues. So that's why we did this study. We're just trying to learn what happens in human behavior when we take something critical away from you. No landmarks, no visual cues whatsoever. Did we really achieve that in this study? Not exactly. You can't just drop 32 people in the Sahara Desert. It's unethical. No one's going to fund your study. So they're working towards it. They blindfolded them. It's a weaker version of what they're trying to ascertain, but sometimes this is how research progresses, bit by bit, interesting experiment after interesting experiment. So even though a football field doesn't really capture getting lost in the desert or mountains, it's still an interesting study just in its own right, especially the way the conclusion happened here. No one made it to the end of the football field. The first time I read this, I thought that was really shocking. I bet you all 32 people were confident that they were going to do just fine, maybe even laughing at the first few people that went off course. And then they realized, oh, I'm just the same. We have more to talk about on this one, sample on the population. I think we've worked pretty hard today. Let's call it a wrap after this. Any last questions at all, folks, before we call it a night officially? Okay, today was really more about introducing the course. These were two really, really long examples. Again, not every day is going to be exactly like this. When we go on to the next set of problems, these are more similar to what problems in my stats lab are going to look like, what quiz problems are going to look like, exam questions. But at this point, we have a good feel for what's going on, and all these ideas just keep on coming back. But have a great night, folks. We're going to turn right to this page when we come back on Thursday's class and just continue through the notes. We'll see you all later. Drive safe. Try to stay dry if it's storming again out there, and we'll be back to it. Yep. Take care. Yep. Have a good one.
Can we just read, the chapter on like our own time and try and have those homeworks done by the fourth?
Yeah,
Be
exactly.
on track?
Absolutely.
Okay,
If any time of the semester you hit a rough spot, maybe other classes are stealing your time, stuff like that, you might go beyond the due date, but you're not going to get penalized for it. So think of this as just pacing for the course.
okay, cool.
Any snacks come up, don't hesitate to email or just mention in class. I'll be happy to help out.
Okay, thank you so much.
Yep. Take care.
just had a question.
Sure.
Over the weekend, you get, that assignment's due on the fourth, let's say we do the homework,
Mhm.
and it's done, and if we feel like we need more practice, are there other practices?
I believe there's other ways to get more similar questions in that section, but I'd say the best practice would be if you go to the very end of the textbook, there's even more similar problems on that electronic textbook. So you can just scroll into just more additional questions that are similar to the ones you were looking at. And that would be a great set of additional practice as well. On top of that, I'll be posting, as we get closer to the exam, just a whole new slew of questions as well. They'll for great practice questions. And if you'd like to see practice questions even sooner, I'm happy to post the sample exams material a little bit earlier so you can start practicing even more questions.
And, Word document or PDF that you were editing and making notes on,
Yeah, this one here.
can I take a picture or are you gonna, or could you put that on?
I definitely post each one of them. Yeah, absolutely. You're welcome to take a picture, but the next step I do, if you want to take a look, is I deleted it from right over here, so it's gone now. But that was the old version. The next thing I always do at the end of class is go here, create files, browse, go to the thumb drive, and that's the wrong folder. Pull this one in, replace it. Canvas is kind of weird. It was like 2 steps in Moodle last semester. And this is that one with all the solutions that we put in to date. So we'll be doing that with all these notes. And that's why I have the blank notes up here, because sometimes you might want to practice these problems again. It's like impossible when you see the solutions written in. So these are the blanked out ones, and these ones get edited as we go.
I really don't think writing notes on my computer is more like, it moves like my handwriting really fast.
Yeah.
By that and like, how to solve it.
Yeah, I see it. See what you mean.
Sometimes it doesn't type the way I want it, or when you were making edits on, like with arrows and stuff. I'm trying to do that both with Word box and Play.
Yeah.
And so like I'm trying to solve it while trying to listen to you truly, and I just can't, so.
I hear you.
I think it'd
Yeah.
be better if I printed off the notes beforehand and then.
Yeah, that's a good strategy. And there's actual real neuroscience about learning that says, I don't know why this is, but when it comes to retaining information, people who type their notes do not retain as much as people who write down their notes. It probably has something to do with the action of writing something down is a more complicated neurological process. Anything you combine that's really keeping your brain active as you're learning makes that information stick better. So that is a pretty good strategy. It's not everyone's favorite way to go, but actually handwriting your notes is amazing for retention.
Yeah, there's, I don't know if you, I don't know if you're interested, but I am, and I listen to a lot of podcasts. There's this one guy named Andrew Huberman. Don't know if you know him.
I do not know.
He's a neuro professor at Stanford, I believe. And he does a lot of podcasts on like education on neuroscience, and he was talking about like recalling like information.
Yeah.
That was actually a big part of what he was talking about, what you just said, so.
It's pretty interesting. Yeah. I don't know why that works, but yeah, if you combine more things going on in your head with what you're trying to learn, somehow it sticks. It's really interesting. It's like you're lighting up more of your brain for some reason. And that is just a big part of learning. More connections, maybe. It's hard to say. Yeah, neuroscience is pretty amazing. It's like one of those black sciences that has more questions than answers, but they're learning more all the time.
Well, all right, well, thank you very much for your help.
Yep, you bet.
Appreciate it. See you tomorrow.
See ya.